And now let's finish this lesson up. We are on example 5, finding volumes using shells. I'm going to have to move the screen down so you can see our drawing a little better. We're looking at the region bounded by the curve y equals 4 minus x squared, so that's this parabola right here. I don't know why the picture has been cut off, but it certainly has been. Y equals x, which if you can see is this part right here. And then x equals 0, which is this section here. So we've got this shape right here. Again, I apologize. I don't know exactly why the picture has been cut off, because it certainly was not cut off on the slides. But we can work the problem anyway. We're going to take this region right here, and we're going to revolve it about the y-axis, and we're going to find the volume. So now let me attempt to make a drawing here for you. So we're going to imagine we're going to take this line right here, and we're going to revolve it about the y-axis. Please feel free to laugh at home at my pathetic drawings. Look at that beautiful straight line right there. And there's my cylinder. You see the cylinder right there. Now also remember that in order to find the volume, we were taking all of the lateral areas, which we found by going 2 pi rh, and adding them up. Well, how am I doing this? Well, 2 pi is 2 pi. What about the radius? Well, the radius is just some amount that I come out. It's just some horizontal amount, whether it stops here or it goes here. Yes, and we had to make a little pause there. I know you didn't see the pause because I stopped the video, but you know, people just love me and keep coming into the room. I can't help it. I'm just such a wonderful person. So again, we were just talking about how the radius is just some value that we go out horizontally, so we'll call it maybe x. The height, though, how do we find the height? Well, the height starts at this top blue line and goes down to the bottom blue line. So the height is the difference between the two functions. Well, this is the upper function. This is the lower function. So if I subtract those two, that gives me the height. So I now have this. There's 2 pi times the radius times the height. Again, there's the upper minus the lower. Perhaps you're wondering about this 1.562. The way I got that, of course, you see we start at 0. That's very obvious. But the question becomes, what is that x value right there? Well, all I did on my calculator was I sketched 4 minus x squared, and I sketched y equals x. And then I went to menu, analyze graph, and then told it to find the intersection. Or if you're on the old 84s, you go to second trace, which is calculations, and tell it to find the intersection. Either way, it gives you the 1.562. Then we use our calculator to come up with this interval. Don't try and mark this one out by hand. It wouldn't be too bad, again, but for that 1.562. So 13.327 units cubed. And now let's move the screen back up just a little bit. This is one of my favorite problems. Making a paperweight. A mathematician has a paperweight made so that its base is the shape of the region between the x-axis and one arc of the curve y equals 2 sine x. Each cross-section cuts perpendicular to the x-axis, and so on and so on and so on. Now, of course, only a mathematician would make a paperweight that follows the pattern of a trigonometric function. Yet we are special that way, ladies and gentlemen. You should appreciate us. So our job is to find the volume of this paperweight. So again, going to the idea of using cross-sectional areas, if I look here, and it's kind of hard to tell because of how it's drawn, but each of these cross-sectional areas is a semicircle. And so if I were to find the area of every semicircle starting at 0 and going all the way to pi, and now I'm back. Now I know you didn't see that there was a long gap there, but I've had people coming in the room because, as I said just a moment ago, I am such a loved person. So I'm going to try and remember where I was 10 minutes ago when I paused the video. I think we had just started talking about how we're going to take and find the area of each of these semicircles from 0 to pi, and we're going to add them all up using an integral, and that's how we're going to come up with the volume. So this is the formula I'm going to use. You know that the area of a semicircle is 1/2 pi r squared. So 1/2 pi, and this would be the radius. Well, you say, well, why is it sine x? Why is it not 2 sine x? Well, 2 sine x would be the entire way across. That would be the diameter. We don't want the diameter. We only want the radius. So I take half that distance That's why it's sine x instead of 2 sine x. And then again, I'll use my calculator from 0 to pi and come up with 2.47 cubic inches. And we end today not with a math problem, but just with a principle. Cavalieri's volume theorem, and I'll let you do all the reading, but I will summarize it for you. If you have two shapes, and they do have the same cross-sectional area at every level. Now you look at these two shapes, and if you were just take a slice of them at every level, even though it's bending there, just a single slice at any level, it's going to be the exact same shape. And the vertical height is the same. You know, see, from that base to that base, the bend to side, that base to that base is the same as this one. Then even though this is a slightly different shape, these two do have the exact same volume. But I would encourage you to pause the video and read all this and read about the man here. Just some interesting stuff. And ladies and gentlemen, here's your homework assignment. A longer one today, but as always, we'll work on it in class tomorrow, and please come with lots and lots of questions.